So welcome to this complex analysis class. This session, we are going to do an example on how to evaluate integrals along different paths. So here's the problem. Evaluate the integral along the curve C, 1 plus I minus 2 conjugate of Z, dz along the curve connecting the points Z1 equals to 0 and Z2 is 1 plus I. So the first part, the straight line, connecting Z1 and Z2. And then B, the parabola y equals to x squared. And then number C, the broken line Z1, Z2, Z3, with Z3 equals to 1. This is a nice problem. It's simply testing on whether you know how to carry out contour integration following different paths specified by the C curve. Now, what you're going to do is to remember that the general contour integration is given by the solution. We know that integral of f of z dz along C can be written as integral f of z is a function which is given in terms of u plus iv, and z is given by x plus iy. So where there's f of z, we put u plus iv, and then dz means dx plus I dy. So dx plus I dy. And then you can rearrange this one as integral. So u dx plus u I dy plus iv dx. I times I is -1, so negative v dy. So when you rearrange these terms so that we have real parts and imaginary parts separated, we'll have integral u dv, u dx minus v dy plus I, and then this one is v dx, and then plus u dy. So that is how we can write any contour integral of a function f of z. So the thing is that what we have been given, we are going to rewrite it to take this form. And we know that z is always given by x plus iy. So which means the conjugate will be now x minus iy. So we are given that our integral is of the form 1 plus I minus 2 conjugate of z dz, which is the same thing as saying integral. So 1 plus I minus 2, where this by z or conjugate of z, we write x minus iy. That's just by definition. And then dz is the same as dx plus I dy. So when you simplify this, we'll have integral. So 1 plus I minus 2x minus minus is plus, and then so we'll have plus 2y I. Remember, this is I, and then times dx plus I dy. So which will be integral. So 1 minus 2x, and then plus, I say 1 plus 2y, and say I, and then dx plus I dy. So which will be integral along C. So if I take those without I, so I multiply this by this one, I'll get 1 minus 2x dx. And then this term and this term will give me minus. Now 1 plus 2y dy, then plus I. So this term and this term and this term will give me the one that has I, also this term and this one. So I'll have 1 plus 2y dx plus 1 minus 2x dy. So therefore, we need to be dealing with this integral to solve part A, B, and C. So this is the integral that you are given. So the integral that we are given in the question is the same as what we have here. Now, so first one is straight line. So part A. Joining Z1, which is 0, and Z2, which is 1 plus I. So let's sketch this on a diagram. So remember, this is the imaginary axis, this is the real axis. So this is 0, and then so the point 1 plus I is the same as this point here. Have coordinate 1, 1, only that this is now, this will be I. So the line joining this is Z2, which is 1 plus I, but the coordinate is just 1, 1. So this is the line joining these 2 points. So which means that then now we're simply integrating. So from this value is 1. So I'm integrating, if we decide to change all the values in terms of x, the equation governing this this line here, remember this is usually the x and then this is usually the y. So line joining the points, this is 0, 0, and this is 1 plus I, but the same, this point is simply 1, 1. 1, 1 is simply y equals to x. So then if we use the limits of x, so x will be changing from 0 to 1. And where there is y in this equation, we replace by x, and dy equals to dx. I just using this equation. So that now our integral will be integral along C of 1 plus I minus 2 conjugate of z dz is equals to integral. Now we are using the limits 0 to 1. We have already reduced this into this form. So we have 1 minus 2x dx and then minus 1 plus 2y, but y the same as x. So 1 minus 2y plus 2y. But y is the same as x. So we want to change all our integral in terms of x. And then dy is the same as dx. Plus I, integral from 0 to 1. Now here, this where there's every place where there's y, you replace by x, and where there's dy, you replace by dx. So we'll have 1 plus 2x dx plus 1 minus 2x dy. It's still dx. One minus 2x dx, because y is being replaced by dy is being replaced by dx. So we'll have now integral from 0 to 1. We'll have 1 minus 2x minus 1 minus 2x dx plus I 0 to 1, 1 plus 2x plus 1 minus 2x dx. And this will be simplifying to 1 minus 1 is 0, so minus 4x dx plus I. Now this and this cancels out, so we'll have 2 dx. So this will give us minus 2x squared, and then 0 to 1 plus I 2x from 0 to 1. So which will be, the first one will give us minus 2, and then this one will give us just 2 then times I. So the answer will be minus 2 plus 2I. Part B, along the parabola, y equals to x squared. Remember the question was evaluate the integral along the following curves connecting the points. So the main thing is that we have the point z1, which is 0, and the point z2, which is 1 plus I. So we are within those limits. So let's sketch the parabola within those limits and see how the curve looks like. So this is a point 1, 1, or the point z2, which is 1 plus I. And if you draw a parabola, this is how it looks like. Just show proper diagram. So y equals to x squared So remember, this is the x, this is the y. So this is the point 1, 1. So this is 0. This is a point z0. This is a point z1. So along this curve here, y equals to x squared means dy equals to 2x dx. So we decided to change. Remember, we are dealing with the integral long C of 1 plus 2x dx, and then minus 1 minus 1 plus 2 Remember, after changing our integral in terms of x and y, we had one minus 2x dx minus 1 plus 2y dy. So 1 minus 2x dx minus 1 plus 2y dy plus I 1 minus 2 1 plus 2y, and then 1 minus 2x. 1 plus 2y dx plus 1 minus 2x dy. So this is the integral we have. So along the parabola y equals to x squared. So where there's y, you put x squared, and then where there's dy, you put 2x dx. And then because we are using now limits for x is changing from this point to this point where they're intersecting. then change in x from 0 to 1. So we'll have the integral 0 to 1 minus 2x dx minus 1 plus 2, but where there's y you put x squared, where there's dy you put 2x dx plus I 0 to 1 plus where there's y you put x squared and then dx 1 minus 2x, where there's dy you put 2x dx. So just replacing now, we're changing the form of the integral to be purely in terms of x. So we'll have the integral from 0 to 1. So this one will be 1 minus 2x. And then, so remember these are 2x here. So 2x times this, and this minus will have minus 2x. Minus plus is minus. 2 by 2 is 4. X squared by x is x power 3. And then plus I 0 to 1. So this would be 1 plus 2x squared plus 2x times 1 is 2x. And then minus 2x times this one will be plus minus 4x squared. And then dx. So we'll have integral from 0 to 1 minus 4x minus 4x power 3 dx plus I 0 to 1 now be minus plus 2x, this and this will be minus 2x squared. And then dx. So integration of this is x. This one will be minus 2x squared. This will give us minus x power 4, 0 to 1, plus I. This will be x plus x squared minus, this will give us 2 over 3 x power 3, 0 to 1. Because every term has 0, then has x, lower limit will be 0. So they're the same as 1 minus 2 minus 1 plus I into 1 plus 1 minus 2 over 3. So which will give us 1 minus 2 minus 1, just minus 2. 1 plus 1 minus 2 over 3. 2 minus 2 over 3, which is 4 over 3. So the plus 4 over 3 I. So that will be the answer to the second part. And the last part, C, they want us to move along broken line Z0, Z1, Z2 and Z3. So Z1, Z2 and Z3. So this, remember, we call this one Z1, not Z0. So this Z1, this Z2. Just for notation of convenience. So sketch the region. So this way I have the Z1. So we'll have Z2 and then Z3. So this one, this point is 1, 1. This point is simply 0 or 0, 0. So this along the Y or the imaginary axis, is along the X or the real axis. So this is the line, and then there's this broken line. So to integrate f of z dz, is the same thing as what we have been given, integrating f of z dz. So we move from z1, then we go to z3, then we go to z2. Objectives to integrate from this point to this. So we walk from here to here, and then from here to here. So we can split this into two, saying will be the integral from z1 to z3 and then plus integral from z3 to z2. So this is an integration along the broken line z1, z2, z3. So remember this, this parts here, z1, z3 is simply the x-axis. So remember this z1, z3, this is just the line, the x-axis, or the line y equals to 0. And this other one here, this vertical line, z1, z3, z2, is simply the line given by x equals to 1. So this path is the curve x equals to 1, and this other one is the curve y equals to 0. So which tells us that to evaluate the first integral, f of z dz along the line z1, z3, we are working with the line y equals to 0, that's the x-axis. And you see y equals to 0 means that dy equals to 0, and the limits we have, x is changing from 0 to 1. So in our expression, we'll be replacing limits from 0 to 1 for x, and where this y, you put 0. I remember we had the integral along C of 1 plus 2, 1 minus 2x dx minus 1 plus 2y dy. This, remember we are referring to this. Yeah, so 1 minus 2x dx, 1 minus 1 plus 2y dy. And then plus I, 1 plus 2y dx plus 1 minus 2x dy. So in this one here, we'll have along this path, we have integral 0 to 1, and then 1 minus 2x, and then dx. And then because dy along this path is 0, so this term will not be there. So there's no need of us writing here. So because will be now 0 times 1 plus 2y, just be 0. And then plus I 0 to 1. Where there's y, we put 0. So just have 1. And then dx, dy is 0 along this path. So this is the only integral that we'll have. So that will give us 0 to 1 of 1 minus 2x dx, and then plus simply I dx. So when you evaluate that, we'll have x minus x squared, and then 1 to 0 plus I. So when you integrate this, you get x, and then limits from 0 to 1. But this 0 to 1. So would be 1 minus 1 squared, which is 0, and then this will just be plus I. So this simply given by I. So the next thing now will be now to evaluate the other part. So which is given by. So the next one is Z3, Z2 of f of z dz. So remember for that one, we have the line x equals to 1. So x equals to 1 implies that the x equals to 0. And now because we're moving vertically, so we are using the limits of y. So we'll be using the limits of y because this is the 0.10 and we are going up to this 0.11. So y will be moving from 0 to 1. So then limits will be limits for y 0 to 1, and where there's dx will be replaced by 0. So therefore, in this definition of the integral, where we have integral from 0 now to 1 minus 2x dx minus 1 plus 2y dy plus I 0 to 1 plus 2y dx plus 1 minus 2x. These are the integral and now putting in the limits. And therefore, where there is dx, you put 0. So this will be 0. And where there is x, you put 1. So this you put 1. And then this one you put also 1. So therefore, the limit, the integral will be 0 to 1. So we'll have 1 minus 1 times 0 is 0. So this part will not be there. So all these will go to 0. This other one will give us minus 1 minus 2y dy, and then plus I 0 to 1. So 1 minus 1 will give us 0. So this just be 0 dy. So actually this is going to be 0. So that now we concentrate with this part. So this will be minus y squared, then limit from 0 to 1. So this will give you minus 1, which is minus 2. So therefore, the whole integral will be integral through the broken line z1, z2, z3, integral of f of z, dz, integral z1, z2, z3 of f of z, dz, which is given by z1, z3 plus z3, z2 to z, f of z dz will be, this one gave us I, this one has given us minus 2. So which is simply minus 2 plus I. And that is what so we have minus 2. So just okay, this part this part here was now replacing by, really this is not 0. Just small correction there. This is not going to 0 because when you replace this by 1, so I'll have I. So this part is what goes to 0. But this will be 1 minus 2x. So this will give 1 minus 2, because 1 times minus 2 is minus 2. So plus 1 is minus 1. This will be minus dy. So this would be integral 0 to 1 of minus 1 minus 2y dy. This one will give us minus I, because we are using limits from 0 to 1. So that this will be minus 2 minus I, because the answer, so the answer to all this integral will be minus 2, and then so these are plus minus I. So there's a minus I here. So I'll have finally minus 2 minus 2 minus I so minus 2 minus I. So the first one was I. So I'll have I minus 2 minus I. So I minus I is 0. So this, the answer will be minus 2. So the final answer to that problem will be minus 2. Because I and minus I cancels out. So this and this cancels out to give us minus 2 as our final answer. So that's how we solve such a problem. Thank you.